contained in properties of elements. The recurring of similar properties of that element after certain definite interval when the elements arranged in order of increasing atomic number in the periodic table is called periodicity. Then the cause of periodicity is the repetitive of similar electronic configuration of the atom in the valence shell after certain definite interval. These definite intervals are 2, 8, 8, 18, 18 and 32. Periodicity is observed in a number of properties which are directly or indirectly linked with the electronic configuration. Then periodic trends in a physical property, atomic radius. Atomic radii generally decreases across the period and increases on moving from top to bottom in the group. Then atomic radius is of three types. The first, crystal of metallic radius. It is one half of the internuclear distance between the two nearest atom in the metallic lattice. It is generally used for metal. Then covalent radius. It is one half of the distance between the center of the nuclei of two similar atoms joined by a single covalent bond. This is generally used for non-metals. Then van der Waals radius. Van der Waals radius is a one half of the intermolecular distance between the two adjacent identical atoms belongs to the neighbor molecule of elements. Then additional information, the atomic radius of noble gas or inert gas are in effect van der Waals radii since they not form molecules. Then van der Waals radius is greater than metallic radius and greater than covalent radius. Then ionic radii. Ionic radius, it is defined as a distance between the nucleus and the outermost shell of an ion, or it is the distance between the nucleus and the point where the nucleus exerted its influence on the electron cloud. Then the ionic radii of the element exhibits the same trend as the atomic radii. Next, the removal of an electron from an atom results in the formation of cation. Next, a cation is smaller than its parent atom because it has a fewer electron with its nuclear charge remain the same. Next point, more the electrons are removed, the smaller the ion become. Thus Mg is greater than Mg positive is greater than Mg2 positive. Next one, negative ion is formed by gain or one or more electron in the neutral atom, and thus the number of electron increases but magnitude of nuclear charge remain the same. Due to decrease in a nuclear charge per electron, there is an expansion of outer shell. Thus size of an anion is increased. O2 negative is greater than O negative is greater than O. Next, I negative is greater than I is greater than I positive. It can be explained on the basis of Z by E ratio, that is nuclear charge upon number of electron. When nuclear charge upon number of electron ratio increase, the size decrease, and when nuclear charge upon number of electron ratio decrease, the size is increases. Atom or ion having same number of electron but different nuclear charge are called as isoelectronic species. For example, Na3 positive, N3 negative, O2 negative, F negative, Na positive, Mg positive, Al positive, Al3 positive, 10 electron S and P3 negative, S2 negative, Cl negative, K positive, Ca2 positive, Sc3 positive, 18 electrons. In isoelectronic ion, the size decreases if Z by E increases. Greater the nuclear charge, smaller is the size of the ion. Thus, cation will greater positive charge will have a smaller radius, and the ion with negative charge will have the larger radius. Then ionization enthalpy. It is the energy required to remove an electron from an isolated gaseous atom is in a ground state. If gaseous state atom is to lose more than one electron, they can be removed only one after another in succession and not simultaneously. It is known as successive ionization energy of potential. IE3 is greater than IE2 is greater than IE1. The screening effect or shielding effect. In a multi-electron atom, valence shell electron experience less attractive force due to repulsion between inner shell electron and valence electron. This is called screening effect or shielding effect. Factor affecting ionization enthalpy. Size of atom. Ionization enthalpy is inversely proportional to size of atom. Nuclear charge. Ionization enthalpy is directly proportional to a nuclear charge. Screening effect. Ionization enthalpy is inversely proportional to screening effect. Complete filled or half filled orbital. It is comparatively difficult to remove the electron from these orbital. Then type of electron involved. Ionization enthalpy decrease in order of S is greater than P is greater than D is greater than F orbital. Then ionization enthalpy decreases down the group due to increase in the size of atom and screening effect entering electron. Then next, generally the first ionization enthalpy increases along a period from left to right as the charge on a nucleus increases while valence shell remain the same, leading to increase in a effective nuclear charge. Then additional information, Schalter value. uh, Schalter value for determine of Z effective. Z effective equals to Z minus sigma. Z effective is a new effective nuclear charge. Z is a total nuclear charge and sigma is a Salter screening constant. Sigma equals to 0.35 into number of other electron in a nth shell plus 0.85 into number of electron in n minus 1th shell plus 1 into total number of electron in the inner shell. Atomic radius is inversely proportional to Z effective. Ionization enthalpy is directly proportional to Z effective.